Hello, 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 hello. How is everybody doing today? So back with the submarine. How's it going there, Zachy? How are you? So going to be working on the sub here. Same old thing. I want to get this kind of moving forward as much as possible, so that I've got some time. I believe it's December 17th. This is due, so I have plenty of time, but want to get ahead on it. So that by the time I start wanting to move on to something else, I can. So let's see. I think what we should do, so the airlock is pretty much good. Finished that up yesterday. I want to work on the ballast system. I'm trying to go systems, then cockpit or bridge, so that everything's going. I don't think I'm going to do passive ballast. What I think I'm going to do is we'll do full pumps. That way I think I'll get better control over everything. So we'll do that instead. What are we running there? Okay. Why am I looping like that? What is the dealio here? Okay, I'm going to get rid of passive altogether here. Well, redo this ballast system a little bit here. I need to put in fuel tanks as well, but we can adjust the ballast for that. That's where this will go. So we'll do pump in, pump out. So let's actually delete that. Let's delete that. So I did some testing. The large fluid ports are not giving me any higher of a flow rate, so there's no point in putting them in if they're not actually increasing my flow rates. There's really no point to that, so we won't bother with that. Put in small fluid ports. Trying to decide if I want to set this up to balance with water. I don't think I do. I'd rather trim it out with fins. That's going to be a more active and quicker way to do it, so. Do fluid port here. Alright, and then what we'll do is we'll do pipe corner here. We'll go forward here. Okay. And then what we'll do is we'll do liquid here. Alright. Then we'll do pump. Curious about how these are going to act low in the water. You can only the small pumps here can only pressurize up to 10 atmosphere. So theoretically, if the ocean is at 30, you're not going to be able to pump out at the lowest parts of the ocean. But if we can increase the air pressure in this volume up to, say, 20, we can pump out. So we're going to go with that assumption that we can do that. Alright, so this will be here. We'll do fluid. So this is just a little bit more configurable doing it this way. And then we want a pump. Right, and then we'll go grab liquid. Where's liquid? There it is, liquid. Alright, so there's pump in and out, just to make it simple. We have a little bit of a space constraint here, so I don't want to make it overly large. And then we'll copy that, and we will go and we'll grab all this. I'm going to put a couple of these in to expedite filling and emptying of ballast. So that will be one there. And then we'll put another one. Can I get it? Where can I put it so it's not in the way? Let's keep moving it up. Let's go right there. These new fluid ports are nice because we can get them right up against the other ones. I like that the devs are starting to do that where they're kind of a little bit more space conscious. Alright, so that's going to be pump ins, pumps outs. This area here where I go into the wall, I'm probably going to make that fuel tanks right here. This currently water can get up in these side hips. I'm going to probably turn that into fuel. Because you want your fuel at center of gravity. So as you burn fuel or as you utilize fuel, the ballast of that's going to go down, and so you want to go straight up. You don't want, like if I put my fuel tanks in the front as I use the fuel, the bow is going to become light. If I put in the tail, same thing. As we burn fuel, it's going to give us an imbalance. How's it going there in power? Yep, working on the submarine for Big Man's Challenge. Oh, nice. You got your airlock working, Zachy? That's cool. Nice. That is good. Yep, especially it's nice to do something for the first time, to learn something new. Cabinetry there. Okay, good. So that is all set here, I think. So we will put in fuel here at some point. We'll reorganize some of this. Ballasting's going to take a little bit of work here. So, personally, I'm not worried about too much balancing. When I started out, you notice I have a ton of battle cans in here, a lot of weight down low. As we build up, as we change the mass inside the cabin and everything else, we're going to have to keep balancing. That's fine. I kind of expect that. So, just we'll have to keep balancing throughout here. So, kind of expect that. So, let's next make sure we get this ballast system working. So, grab a blank microcontroller. We'll start working on this. Alright, so this is going to be the ballast system. Alright, ballast system there. And what I actually want to do is, one of the reasons I brought up the whole fuel business is I should block these off so that water can't go into the ballast tank, into the fuel tanks. That way I know that I don't need that space for ballast. So, should be pretty clear I'm not going to, but we will check it out. Alright, so let's look at the way the system's currently working. So I have 2 large pumps in the bow. I have 1 medium tank. This medium tank, starting with 15% air. I might get rid of that. I probably will get rid of that. We'll see. I kind of want to check. Let's check something here. So let's take a dial. Take 2 dials, actually. So I'll put 2 dials here right on the bow. I'm going to take the nodes from this tank. So we have tank pressure. Am I doing it in the cockpit already? I think I am. I'm already doing this in the cockpit, so we'll just use the ones in there. So we have this tank here. Let's see. We are taking the tank pressure is going on the bottom. So let's see. All right, so that's the barometer of storage. And then what do we have here? Tank contents. We'll go tank contents here. So this is, that's gas ballast. Okay, gas ballast. And then what's running these? Which button? The top button, this one here, what's that? That's valves toggled. Which one's doing this? Fluid pumps. Okay, so that's pumps and that's valves. Okay, so that's going to give us, I want to see, so what I'm going to do is I'm going to start with this tank empty. And I'm going to completely suck the air out and see if we can fill the air in there. So I need to do a gas meter in here. So I want to see how much air I have in this ballast tank. I want to suck it all out, make sure that the tanks are enough to completely take it all. So I need, what are you? Liquid ballast. Okay. Let's do another dial here. So I want to figure out all my parameters here so I know how big my tank's going to have to be and everything else. So this here is going to be the gas level right there. Okay. So this is gas level ballast. All right. So that should be able to run that. So let's do this. I'm just going to suck the air out of that and put it into the storage tank. Make sure that my storage tank is essentially large enough. I'm not going to put any water in, so... Alright, so here's the gas ballast, as you can see. So that's the tank is starting to fill. The level in here is starting to decrease. So we should be alright. That's a full-size medium tank. I putting the whole room behind me, the whole airlock into a small tank. That's a medium tank, so should be able to fit all that into that one tank. So kind of the plan is I want to... I might add some pressure to that tank because I want to pressurize my ballast. I don't want to pressurize my living space. I don't want, and I don't need or want high pressure in my living space, but I do want it in the ballast tanks because that will help get the water out. So you can see the gas ballast is going up. this is barometer, this is atmospheres. So once we hit 60, we're done. So this is going to be a limitation. This will slow down. The higher the pressure in the tank, the harder it's going to be to push more air in there. Currently only at 34 atmospheres, and we only have 1,000 left. So the likelihood is that we're going to get this tank full before we hit 60. And then what I need to do is figure out how much is left. And so we can do a little math on that. What do you, baro ballast? So this is the barometer. This is the pressure in the ballast tanks. So currently, the ballast tank is at 0.22 atmospheres. So of course, we're creating a vacuum in there. This is going to help the water come into our tanks because we're essentially creating a vacuum in our tanks. So when the water tanks, when the water pumps turn on, it's going to be easier to get the water in because it's going to be fighting lower air pressure, essentially. So as you notice, liquid ballast is at 0. We're not pumping any water in the tanks. We're just working with the gas now. So as you see, we're at 40. We only have 700 liters left. Barometer ballast. You know, it is going to slow down if I pressurize the system because the closer we get to 60, the more force we need to get to cram more air in those tanks. So we could run into an issue with that, but I'll take a look. Let me see. I'm getting messages here. Getting random messages from people. Okay. All right, so we're up to 40 atmospheres. And we're down to 600 liters of air left in there. And so the main thing of what I want to do is I want to see... So what I'm going to do is I'm then going to fill the gas tank all the way full. I'll just do a test tank. How's it going there, Timotheus? I'm going to fill one of the tanks up to maximum. I'm going to see how much air it will hold. Let's say it's 4,000 liters. If I'm putting 2,000 liters in, and I know the tank can hold 4,000 liters, and I want to pressurize my ballast tanks, what I can do then is I know I can pre-fill the tank to 2,000 because it can hold 4. My empty ballast tank is 2,000. You know, 4 minus 2, I can put in 2. So I can pre-pressurize the tank to 2. That way, for example, when we want to push the water out, instead of doing it at 1 atmosphere, we might be able to do it 2, 3, 4 atmospheres. That's going to help to push the air out, or the water out of the tanks, so that in the event that we're all the way at the bottom of the ocean, the pumps will take care of 10 atmospheres. The air will take care of the other 20 atmospheres, and that way we can pump out even though we're at the bottom of the ocean, which is important in the event that you had a failure. You still want to be able to open up your air valve, and you want to be able to flood the ballast tanks with air for to be able to do an air blow, to emergency blow your ballast, or else you could theoretically get stuck at the bottom of the ocean. So down to 400, as you notice, it is slowing down. It's going to slow down. It has to fight the air pressure to get in there. So one way, if you want to speed this up, you add more tanks. So right now, if we had 2 medium tanks, it would be at 21 atmospheres. Or it'd be 21 atmospheres because we're splitting, we're having the volume. We're doubling the volume so that it can be at half the pressure, essentially. I have a question for the Build Challenge Hotel. I have built/am building a truck and trailer combination. Is it possible to spawn both at the time in the train base? Yes, it needs to be spawned at the same time. So it needs to fit in there together. Yeah. So you can have tractor trailer for the hotel challenge. They just have to spawn together. You can't like make a trailer that needs to be spawned separately because it would get around the rule of it has to be able to be spawned as one unit. So, yeah, but as long as you can spawn it together, you're good. Yeah, you should have plenty of room. That could take like almost a 100-foot long train car in there. So, you notice again, this is going slower and slower. The higher the pressure, the longer it's going to take. Not a big deal because, you know, we're going to be pumping water in this. and we can still travel. We can still, I showed yesterday that because I'm using a dive plane system, I can tilt my thrust and I can still go underwater even though I'm positively buoyant. And so it's not like you have to wait for the ballast tanks to fill to go underwater. You don't. You just go underwater. So that's good there, Timotheus. Yep. So, you know, that's one of the considerations is you don't have to wait. You don't have to wait for it to be 100% full. You notice we're at 0.08, so we're almost pulling a complete vacuum in the tank. This is going to move very slow, so that's fine. What we're going to do here is I'm going to quickly reload. I want to see the numbers, and then we're going to pre-pressurize our tank. So I might add a second tank to decrease it, but does anyone not understand how that as you increase the volume of the tanks, you know, if you double the volume capacity of the tanks, you're halving the pressure. Because think of it as marbles. You're trying to squeeze marbles in this tank. If you double the tanks, right, the marbles now can be twice as far apart from one another. And that's pressure, is squeezing them closer and closer together. All right, so we're going to write down some numbers here. So our gas ballast level, this will change. It's one of the reasons I blocked off the side tanks, which is where the fuel is going to be, is 36, 56.96. Okay. And so that's good. We know that. Let's go ahead and save this. All right, I'm just going to grab a tank. So I'm using a medium in here. So here's a medium tank. Stick it right on there. This will be full. Spawn that. I want to go down there and I want to see what the capacity of a mead is. It can hold, let's see. Not going to get the numbers perfectly, but we'll get close. 5129. 5129 plus. Let's check the O2. 1364. So we're holding approximately about 6,500 liters in this tank. So what that's telling me is that, you know, let me write it down. So a medium tank capacity is 6,500 liters. All right, so and that will be at 60 atmospheres. So this medium tank can hold 6,500 liters. We're only trying to put 3656 in there. So if we want to have a pressurized system, what we could do is we could go up to a value of, let's see. So if we see, so we would do 65. I should probably get it more accurate, but we'll be all right. 6,500. Let's see. Divided by 3656. 1.7 times, okay. So do 3656 divided by 6,500. So that's about, so we can fill, so what we have in our ballast tanks is about 56%. So, you know, we're talking, we can pre-fill this tank to about 44%. So let's undervalue that. So we'll fill this to, like, say, 40%. So we can pre-fill this tank to 40%. And what that's going to allow us to do is, where's my valves button? This is valves right here. Okay, good. So, like, if we set up the system like this, and we go in, if we look the gas ballast, the tank is already pre-pressurized at 31 atmospheres. If you remember what I was saying, the maximum atmospheres of the water pressure at the bottom of the ocean, as stated by the devs, is 30 atmospheres. So if we were to, say, sink to the bottom of the ocean, we need 30 atmospheres of pressure from our air tanks, minus the 10 atmospheres that we can produce in our pumps. We need at least 20 atmospheres in our tanks to be able to get the water out at the bottom of the ocean. If we do not have that much, we can no longer fight against the pressure, and we can't pump out. And so we want to make sure that's high enough. And so this is going to help increase the speed at which we're able to pump out. So here's our barometer and our ballast tank. So currently, our ballast tank is at 0.93 atmospheres. Now, if we start to add this, so this is what's in our ballast, this is what's in our tank. If we turn on our pumps, you notice we're starting to decrease the air in here, and we're starting to fill this up. And so ideally what we'd like to do is get around 60 atmospheres. That's going to really help speed up pumping out. The pumps themselves are going to start pumping the water out, and the air is going to be pushing that water, helping it get out. So it's gonna increase the chance. We're also going to put an emergency blow valve on this, so that in the event that, say, we had an electrical problem or something, we run our batteries to nothing, which we're gonna have some backup systems. We're gonna have an emergency backup battery. We're gonna have stuff like that, but we'll have an emergency power crank, all sorts of stuff like that. But in the event that, say, we were to sink to the bottom of the ocean and, oh my God, we can't empty our ballast tanks, what do? We let all this gas out, and we'll actually do a valve that is passive. So instead of the pumps having to work, what it will do is it will open up a valve that will now allow the gas to push the water out. So emergency blow valve. So here we're coming up on, my 40% number is probably wrong. Yeah, my 40% is too high. You know, so we're gonna hit 60 atmospheres and then we're done. That's actually letting us go over. Okay, we're actually, it's letting us get over. So, all right. Never mind, it's letting us get over. We'll see how high it lets us get over. Might let us do a little. Actually, you know what? Did they set a hard limit on the tanks? They set a hard limit on the pumps. So the pumps have a hard limit of 60. I don't know if they hard limited the tanks, because I'm using 2 large pumps to pump the air into the ballast, into the storage tank. And so if you did 60 plus 60, that's 120 psi's, or psi, atmospheres. You'll hear me go back and forth to psi, and I'll have to correct myself. But you know, as we're able to, so I guess we are able to pressurize past 60 as long as we have enough pumps on there. That's an interesting. I'll have to do some tests on that. But essentially, what we're able to do here is we're able to pressurize this tank up, and that's going to help us push the water out. So that should make sure the system's efficient. This will also be good for emergencies, for emergency ballast blows. So, as you can see, the Barrow, what's this? Gas ballast. What's the? I'm trying to see what the. This is okay. I'm confused what the difference is here. Barrow storage, gas ballast. Yeah, I don't know what that's all about. Something's up with, I don't know which number to read. This would make me think that's the barometer and, oh, this is the barometer and storage? I'm not sure what the difference is right there. But, so we look all right. We don't need this to be a vacuum either. We don't need a complete vacuum. This is going to, you know, we don't need to pull every molecule of air out of here. So it doesn't need to all go into the storage. That's fine, as long as we can pull a negative number, which is, or less than 1, which is a vacuum, partial vacuum, and as long as we can push a positive. So let's stop the pumps. All right, so we have a bunch of pressure stored in our tanks. Now what we're going to do is we're going to go ahead and we're going to open the valves, and you'll notice this number will shoot up. If you remember last time, the ballast tank holds 3,600 liters of air, and we push all that pre-pressurized air in there, and now we're up to 6,000. If we look at the barometer in the ballast tanks, we're at 1.48, so we have a positive pressure in there, so that's going to help us push the water out. So that's kind of the first thing I wanted to do, is check out those numbers, make sure we get this tank pre-pressurized. We're good there. So this is kind of the setup. I'll go over the setup a little bit, but we have 2 fluid pumps here. These are gas valves, so it only allows gas in, so we're not pumping water in our tanks. Comes up here, it goes up here into the pumps. The pumps come up, and they feed this medium tank, 1 medium tank. And then I could actually put a second, nope, 1 block off a medium. I might put another storage tank on here just for funsies. And then it comes over the top here, and it meets up right here in a T-valve, 2 valves. The valves go back, and they push out through, to push us out into into there. These valves are backwards. I don't think it matters, but we'll flip them. These valves are backwards, so I'm just going to flip them. It still works, but I want to make sure it works as best as humanly possible. All right, good. So that is the ballast system. That's the air part of the ballast system. So, you know, this is one of the things I think, you know, net positive certainly for the update. You know, of course, we had growing pains with the update. But the benefit of the update now is that a lot of stuff is working really well. So let's see. This is pumping. What's that? That's valves toggle, pumps toggle. What happened to this? Oh, I accidentally deleted my pumps here when I moved the valves. Okay. Let's leave the valves where they were. They're working fine. Make sure they're all merged up. Okay. I accidentally deleted them. I was like, why are they not connected? All right, so here we go. So if I trigger the pumps, that means I want to pump water into my system. So we're going to go pump in, and we're going to go pump in. If I trigger the valve, which is going to let air into the ballast tank to help me pump out, I'm going to pump out, and we'll pump out, and we'll do a quick ballast run here. And so essentially set this up where what I'll do is I'll set the number of liters that I want, and we'll pump in and out. So I want to pump in. Gas ballast is coming out. It's going into the storage tank. Water is shooting in. The barometric pressure, you notice the barometric pressure is not going down like it was last time. The reason is as the air is going out, water is coming in. As the water comes in, it is pushing on the air to keep the barometric pressure not only static, but as you notice, the air pressure is going up because the water is coming in at such a rate that it's actually outpacing the gas going out. So it's you'll notice that it's going to increase the barometric pressure. So that makes sense. You might see some people, oh, this doesn't make any sense. It does make sense. Is as you pump water into a tank, it's going to compress the air. How's it going there, Slicks, for fun? Hi, how are you? Yep, some good submissions for the challenge hotel. So you see, liquid's coming in. There's no point in going into really ultra detail on the ballast system yet to try to, for example, you know, figure out neutral balance, neutral buoyancy, positive buoyancy, negative buoyancy yet. Because until every piece of equipment is put in this, as the mass increases, I need less water to reach neutral buoyancy, negative buoyancy. You know, it changes all my numbers. So the fine tuning will be done later. You know, balancing, I'm not worrying about, you notice like the bow is up, the stern is down. Not worried about balancing yet because I still have to add all the stuff in the bridge here. I still have to add more decoration. All that stuff weighs stuff, and then I have to move mass around. I have to move ballasting around. You notice we have a lot of hard ballast in the ballast tanks. That is battle cannon pieces. Because you'd have to add a humongous amount of water in order to change from positive buoyancy to negative buoyancy to neutral buoyancy. If you add a bunch of like hard mass in there, then you don't need to pump huge quantities of water. And so like you could theoretically get it where you might have to pump 100 liters. You know, if it's at 0, you're positively buoyant. 50, you're neutrally buoyant. 100 liters of water in there, you're negatively buoyant. If you get the ballasting correct. The problem is if you go on a razor's edge like that, as your fuel goes, you burn your fuel. Well, now 100 liters isn't going to be enough to sink you. You know, you're going to start having air in your fuel tanks, and that's going to keep you from sinking. So liquid ballast is up 2,200 now. As you notice, we are sinking. We're currently still positively buoyant. You notice we're not sinking to the bottom. At some point, we'll go neutral, and then we will go negatively buoyant where we sink. How much do I know about stormworks? Quite a bit, I'd say. Well, you got any specific questions? See, gas ballast there is coming up. Liquid ballast is still going. So you notice the barometer in the ballast tank is now at 2. You know, the water is compressing the air. It's outpacing us getting the air out of there. So what I'll probably do is add a small tank in addition to the large tank. That will probably give that, you know, by adding volume in my storage tanks, I can decrease the pressure, and that will make it easier for me to get more air in there quicker. I don't do anything with the tech tree. Career mode with tech tree, where can I find the refinery? The refinery island moves based on your seed. So the best thing to do is look in your XML, see what your seed is, or unless you remember your seed. Start up a custom game, put in the same seed, and look on the map where the refinery is. It's all based on seed, so the refinery island will be wherever the wherever it is on the seed. So that's what I would do. All right, so 3,200 liters. I'll grab a save file and show you here. So you want to click on the scene file in your save. All right, and you want to just Control F to find. Type in seed, enter, there it is. There's your seed number. I just search for it with Control F and type in seed. And then this is your scene file in here, so go to your directory there, saves, find your save file, go to scene. Type in Control F, seed, and it will show you seed. Oh. I'll show you. I didn't have this up when I did it. Here's your directories. So stormworks, saves, click on the one, scene, Control F, seed, find next. Right here, that's the number. 192.837 is the one I have. Let me get back to this. All right, so now we are, if I click on the right screen here, all right. We're now we're negatively buoyant. As you can see, we're sitting on the bottom, so we don't need any more water in here. As you can see, we have 3,800 liters. We're stuck to the bottom, so it will slowly keep going at the moment. All right, and so what we're gonna do here is we can dump a little bit. So I have this is an on-off valve essentially. So what we'll do is this will be essentially pit controlled likely. So what we'll do is I will type in that I want 3,800 liters of ballast. This will go, as you can see, I opened up my air valve and it pushed them out. So if I want to push them out, and because it'll be pit control, it'll be very precise. So we'll go click, 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 click. I don't need a variable valve. I can use this on-off valves fine. You notice we push some air in there, and we can decrease our liquid ballast pretty precisely. So let's say I want to go down to 3,600. You know, and so the PID, you can imagine, is going to be much more precise than me just clicking and looking. And so what I'll do is I'll have it as a differential so that I'll put a differential in there. So say that I want, okay, I ask for 3,600. I'll let it do, say, plus or minus, say, 10 liters. That way, it's not constantly turn on, turn off, turn on, turn off, turn on, turn off, turn on, turn off, because it's trying to get perfectly on 3,600 on the dot. And if it's 10 decimal places off, it wants to change it. You know, if you have within 10 liters, it will just turn on, turn off. Okay, yep, we're within 10 liters, and it stops. You know, that way it's not clicking on and off constantly. But, yeah, so let's see where neutral buoyancy is. So what we want to do is we can actually test this by driving a little bit here. Not really driving, but you know what I mean. Okay, so we're going to get out of here. All right, so to test neutral buoyancy, this I still haven't worked on my drive system yet. So you notice we're sinking. Let me, I'm trying to get a stop because the actual fins can cause us to raise or lower. Problem is I gotta fix this. I need to do the actual drive system. All right, so we're pretty much stopped. If you notice here, we're not going up and we're not going down. So we're pretty close to neutral buoyancy right now. So we're around 3,600, and we're not going up, and we're not going down. All right, so as you can see, we're actually going down just slightly. See how we're going down just slightly? All right, so what we want to do is we want to push some water out. There's 35. So I can't tell if we're going up or down. We're very close to neutral buoyancy here. We're probably going down just a hair. So then if we push it out for a little bit, we're at 34. Eventually we'll get to the point where we start going back up. That's positive buoyancy. And then if I were to pump this sucker up even more, it's going to sink us all the way down, which it's going to keep sinking, which will be negative buoyancy. So ideally, if you're just traveling around, it's best to do it at neutral buoyancy or close to neutral buoyancy. So once all the parts are in, I'll go over. I'll do the same sort of really simple test. I'll put an altimeter on there. I'll look. I'll see, okay, we are almost completely stationary, sitting in the water column. This range here is neutral buoyancy. Anything more than this is going to be negative buoyancy. Anything less than this is going to be positive buoyancy. And so you'll know that, okay, if I want to go over this rate, if I go over this number, I'll be positive, and we'll go to the surface. Because, like, if I'm just traveling around as a submarine, I don't want to sink. Like, see, right now I'm sinking because we added some water. It's very slow. We can still travel no problem because we have dive fins. You know, we can dive up and down even though we are currently a little bit negatively buoyant. You can see I can still very precisely control this. You know, so it's actually better. You don't need to get perfectly neutrally buoyant because you can then use just the pitch. So it's almost like an airplane where you can do an altitude hold essentially, where you do a depth hold. And instead of having the buoyancy do it, you're now using the fins and the thrust now to keep you. So if you want to be, say, 10 feet off, or 10 meters, or whatever you want to call it, off the surface, you would set that. Of course, that's much closer than 10, but, you know, like you set 1, and it would map of Earth. If you want to go higher in the water column, you set it, and you don't need the ballast to do that for you. You use the dive planes to do that. So, working pretty well. Read some chat. Your is visible in your top left corner when you are in the escape menu. Okay? My is, what are you, I don't have no clue what you're talking about. Oh, my seed, yes. The world seed on the top left, yeah. Yeah, right there. But that's the other way to find it too. All right, so let's go ahead and let's get this going. So I think we've got the numbers pretty well sorted on this, so let's get this going. All right, so ballast system. We want to take in a bunch of info here. So pretty much, I think what we'll do is we'll control this with water volume. Yeah, I think that's what we'll do. We'll control this with water volume. So we'll go logic, composite input, ballast panel. All right, ballast panel. We'll go out to the ballast panel, read that out. Composite output, ballast panel. Okay. And let's see what else we want to do here. Trying to keep this as simple as possible. This is going to be pump. Water in. Water out. Okay. And then we need a number. So this is going to be a number input. This is going to be ballast. Water. Meter. Alright. Let's start working with this. What did I delete over here? What did I have at the end? can't remember what that was. We'll figure it out at some point. I moved something. Okay. Alright, good. So let's start working on this. Let's see. I could do a single keypad would probably be the best thing to do. Yeah, I think I'll do a keypad for most of it. Alright, I'll add a keypad as well. So this will be a number input keypad. That's just going to be easiest to type in. Alright. Might just do work with the PID number to make give us a little bit of variation. Let's see. All right, that's the liquid meter is the process variable. The keypad's going to be our set point. All right. Do property number. P value. Okay. For now, we'll do a constant on. And I'll probably change it later to activate it. Okay. And then I think we'll just do -1 function let's do this. I don't know why do I need to do that. Let's do this one. I'm not going to change it, so I was thinking maybe I wanted to adjust it, but I'm not going to. Alright. So there's our clamp there. And then we'll make Y -1, Z 1. Alright. That will go into these two. Okay, so if it's a positive, we will go water in, water out. These might have to be flipped. Constant on signal. We'll work with this. I'm going to try a 1 to start with. I'm actually going to stick another keypad in here for now because we have to tune this in. So number input, P value, and then we will put it in with the property of it text when we get a sec. All right, good. All right, so that we should be able to run this with a keypad for the moment. So let's do that. Let's add a keypad in the cockpit. This will go to keypad. This will go to P value, which we need another one. P value will go right there. Liquid meter is going to go right here. So the liquid level. We have water in. Is going to be the pumps that pump air into the system and the water pumps that pump water into the system. Then we have the water out, which is going to be the valves and the outflow pumps there and there. All right, so let's make sure everything's connected there. All right, let's test this. Did I put the p-value in? I did. Okay, I just want to double check because I want to make sure that keypad got corrected. Yep, this is. Okay. All right, let's go run this ballast tank here. with the new system. See how it works. Pardon me. All right, so make this p-value a 1 to start with. We'll tune it a little bit better. All right, keypad, let's go. We want, so about 3,500 gave us neutral buoyancy. So liquid's coming in, which is the correct way. So, you know, I talked about I might have had to flip them. So I had it right the first time, which is just sheer bloody luck. So the PID is going directly to a 1. It's capped at 1. And so it knows that I'm very far away from 3,500 liters. And so it's pumping in, it's max pumping. And then as I get close, it will start to go closer and closer down, you know, under 1. Once it goes under 1, it will shut it. So trying to keep it reasonably simple. All right, so we're filling up. Gas is coming out. Beautiful. You know, there's no point, again, going into these numbers now, because when we start the sub out, it's going to be, you know, the sub's going to have full fuel in it. As we burn fuel, let's say we're at half tanks, well, we're going to need more water to reach neutral buoyancy because we've lost that fuel mass. So, things like that to consider. So, you know, pretty much do it on a manual basis here, where as we... Essentially what's going to happen is, you know, we'll kind of know, like if neutral buoyancy is 3,500 now, let's say we had 1,000 liters of fuel. Well, when we're at 500 liters of fuel, we need about 4,000 liters of ballast in order to stay neutrally buoyant. So what I could do is add a system that as the fuel burns, it adds more ballast. That's something I theoretically could do. You know, I kind of like to do a manual. I kind of like to be the pilot. I think it's better that way often, because if you try to get it so that you figure out exactly neutral buoyancy, and you have, like I say, a neutral button, a positive buoyancy button, a neutral buoyancy button, a negative buoyancy button. If anything changes, it's gonna cause you problems. So it's almost better just be like, oh, are we sinking? No, not yet. Okay, I'll add a couple 100 liters to see if we sink. You know. I could go like precision mode and easy mode, where it's like 3 buttons: neutral, positive, and negative buoyancy. Could do that. And then if you want to fine tune it, you could. So that'd be kind of a cool idea, I think. All right, so up to 2,000. We've set 3,500. So now one thing we'll be able to tell if the p-value is too high if it goes off on, off on, off on when we get close to 3,500. If it just shuts off and we're dead money on 30 or close to 3,500, beautiful. If it's off on, off on, off on, off on, we probably need a smaller p-value. So it very slowly goes up to 1, kicks it on, slowly goes down, kicks it off. You know, we want some precision with that. So we're getting there. We are getting there. Well, hopefully once this is kind of... we get a lot of these systems done, it won't be as much going back and forth with some of the stuff. I'll probably take my latest modular engine tutorial, just use that panel for the engine and kind of tweak it. Eventually I should do a generator tutorial, because that way I'll have to keep doing this every time I do a generator. All right, so we figure about 3,500 was where we're suspecting neutral buoyancy was at. So, kind of thinking that's where this number is going to end up. So, set 35. Let's see what it does when we get close. We're within 500 liters right now. 450 at the moment. So we're hoping that the PID will shut this off pretty damn close. If it's not, I need to tweak the number on the p-value. All right, so we're within about 310 liters. All Alright, there within 100 liters. Let's see, how much does it overshoot? Bingo! Look at that. Within 1 liter of where we want to be. Pretty damn good. So that's pretty good, man. That's within 1 liter. That's half a liter. It's going to build up a little bit. I think there is something letting in a little bit of water. I'll have to see where that is. But that's pretty damn good, man. Right. So you notice it changed enough that it wanted to fix it. We're getting a slow... We're getting a slow water intrusion somewhere. I need to see if I have an old valve that I didn't take out. Because I don't want the system constantly kicking on and off. Let's drop this number a little bit, see what happens. I'm wondering where this water is coming in. I was noticing that before. So if I decrease the number, it should let this get over a little bit more before it turns on. So, yeah, that let it get a little higher that time. All right, so we don't want this up-down business here, so I need to figure where this water is coming from. Because the pump should be acting as valves, so we shouldn't be getting any errant water in here. I don't know why that's happening. Yeah. I might have to throw a valve on if this is leaking. I don't think... The water pump shouldn't be leaking. The water pump should be pretty stable. I don't know where the water... Because water's coming in, so water is coming in from somewhere. Oh, I wonder if the pumps are a little leaky now. Wouldn't surprise me. Alright, let's do this. Let's take these out for now. Let's go like this. Let's get a spawner. I might not be able to put it here. I want to do a quick diesel. Put a diesel spawner in here. Yeah, it's not going to go there, so let's back that up. Alright, these are the hips here. This is where the diesel can go in as on one of these. That should be, yep, that's a 1x4. Beautiful. So I can cut that there, and let me see. Can I cut one of these? Probably not. No, not really. Doesn't really matter too much. I can stick it right here. I'm not hurt. I'm not going to be hurt for fuel. So let's put a spawner here, and let's take a meter. I want to see how much diesel I hold. So that'll help with ranging. Let's grab a couple dials. For now, I want to see what my diesel capacity is. So a couple hip tanks on here. Let's see. So that's going to be quite a bit heavier as, you know, we have that diesel ballast in there, and then we'll just cut off some weight as we need. So we have about 1,600 aside. So about 16 liters of diesel. Nice. So that's quite a bit of mass. You know, we just added, you know, almost 3,000 liters of liquid into the sub. So we can take out an equal amount of ballast weight, essentially. So let's see. I'm wondering where this water, like, see, right now the pumps are off, and the liquid ballast is showing 0. So we're not taking any water now. Curious where water is coming in. Very curious where water is coming in here. Let's test the system really quick. Maybe sealing off that liquid helped. I don't know. We'll see. I doubt it, but because the water is still coming in at some point. I don't get why. You know what? I wonder if it's part of the compression mechanics. Ah, shit. So see what happened? My door's all locked up because I got water splashed in here. So I need to empty the airlock and pump that water out to get rid of it. Because that little bit of like that 20, 30 liters of water that just spilled in locked my doors, which is what I want. Because I can't pump out anywhere else really yet. So I want it to lock all my doors so that I can't flood this thing. So it's all flood prevention. So like if you see here, once that hits 0, the lock should come off. It's less than 1 liter is where I set it, so I can get in there now. All right, good. So let's see. I just want to add a little bit here, so let's go to 1. Let's go ahead, and I'm just going to add 15. We'll do 500. And I want to see if the liquid stops, because I don't know why the liquid keeps coming in after it shuts off. That's one of the reasons I don't have any passive flow anymore. Especially if this air volume is pressurized Shouldn't be getting any in there. What did I set? 500 liters. So we're just taking in 500 liters. I'm trying to see why the water keeps coming in after it stops pumping, because it should stop. See how the number is slowly going up? I don't know why that's still bringing water in. Okay, there it stopped. All right, good. Nope, it's going up again. It looks like it stopped now. It's oscillating a little bit, but oh, we'll see. Maybe it is okay after all. It could be. You know what it probably is? It looks fixed now. I wonder if it's something to do with how I had the fuel tank set up. It was leaking into those compartments. That would make sense to me. It's see, the water's still going up a hair. Is it a pressure issue? See if the barometer's changing. Yeah, see, we're losing barometric pressure, which the problem is the devs made it so that liquids are compressible now. So yeah, so see, the liquids are compressible now, so I think it's the compression a little bit. Not a big deal. I can put essentially a deviation in there, which should help fix that. Yeah, I could do that. Put a plus or minus in there, but that's working pretty well now, I think. All right, good. So that's not bad. Let's just lock in that number on the p-value. That's pretty good at 1. We don't really need to vary it anymore, I don't think. All right. Let's come up with a ballast panel I want. My seat that close? My seat, is my seat really that close? I might not be able to put anything right in front of my seat, which sucks. I could turn the panels. So. All right, so what do we want for ballast here? We're going to need the keypad. So keypad has to be part of this. So let's see, what do we want? Water in. Okay. Happened to my musica. There we go. This is going to be water. Ballast. In liters. That's be dial. I don't know if I want dial or gauge yet. I don't know what the full capacity is here. I'll check it in a second. And this one's going to be water out. Indicator 3. Okay, that's good. And this is going to be... let's see, what else do we want to put in here? You can just put air. What do I have? Water ballast. Air ballast in liters. Okay, let's just do that as a dial as well. Let's figure that out in a second. Okay, so that's kind of what I want there. Let's color things up. So I'll do dark blue for water going in. We'll do light blue for water going out. We'll do similar gauging there. Okay. And then this will go with this keypad here. Okay. Cut that, move that up. Right there. All right. Alright, so this is gonna go to where are we at? Where are we at here? Right there. Alright. Alright, so right on off. Okay. Then what do we want here? I want water and air. I need to put an air fill here, so we'll go in. We'll use keypad p-value. This will be air volume. Air volume. Okay. Right numbers here. So what are we on here? 2. Alright, 2 is the liquid. And 4 is going to be the air volume. Okay. Okay. That'll give us a little bit of a readout there for that. And so I'm trying to think of an emergency blow system to get this an emergency. I kind of want to put that in. Really, we could just, just a backup battery is all we really need. Yeah, pretty much a backup is all we really need. So we might just run a backup battery for now. I might do something different later. But we'll stick with that for now. I'll keep it on the simpler side for this moment here. Clean up some of the stuff here. Okay. It's gonna have to be as funky as it is. Okay. Reconnect these nodes. What did I screw up now that I moved some stuff? Air volume is going to the gas meter. Okay, that's good. All right, good. So that's kind of a little ballast setup there. We can kind of get rid of some of this crapola. And that can go as well. All right, good. Let's work on engine controls, I think. Yeah. I'm just going to hit the bathroom really quick, and we'll do engine controls. Alright, so let's see. We want to get this engine kind of up and running. So currently it's going to be a generator. So if we look here, that's what it looks like so far. Engine's in here. It's quite a beefy Johnny. I want to make plenty of electricity. And so currently I have to test my speed out. But let's test their speed out really quick. It is a challenge requirement that this go 20 knots underwater. So that's, since it's a challenge requirement, we need that. So let's set up a quick thrust setup here. Okay, that's set up. Let's get this, do a quick thrust controller here. I'm just going to do a really quick one, then we'll replace it later. Okay. Alright, so really simple here. I'm just going to do 4, which is up, down. Do an up down counter. Enable that. -1 to 1. 0.001. Okay. It's got to be 31 for the trigger, I think. I think 32 is the occupado. That goes there. All right, so this is going to be thresholds. Threshold of 1. -1. -1. Right. Now go to the motors there. So I just want to do a quick speed test, make sure we're going to hit 20 knots with this vehicle and this engine configuration here. That's 7 motors I have on here each side, so 14 total small motors running that. Let's go on the seat, configure the seat, up, down, sticky 100%. All right, let's go ahead, spawn this. Let's just go do a quick drive test. Come back up out of the water, please. I don't want to leak water in there and lock my doors and have to undo it to seal. Okay, there we go. All right, so that hits it right there. Let me just check. 10 point, we're a little bit short there. We're 19 and change. So 10.3 we hit, let me see. 10.3 is going to be close. 10.3 times 1.943844. 20.02, so that hits it. So I'm going to make it a little bit hybrid, so that will hit the... So this is the minimum speed that Big Man has set for this challenge, so I need to make sure I do that. You notice how we naturally roll? That is naturally what happens. It will happen in airplanes as well. Is, you know, we're changing the mass of this vehicle, right, is mostly at the bottom. And so as we change directions, it's going to bank. And so that's what happens in airplanes too. I'm not going to bother controlling it with roll. There's going to be no roll control. It is, because this is inherently stable, I don't have to. As I turn, it should bank into the turn. And you'd want this too, because imagine you're standing in your submarine, right? If you, like, you see people do this all the time in games, they'll do a handbrake turn. You get thrown against the wall. If you'd make your turn in the submarine like this, as the submarine banks, your feet are still planted on the ground. The G-forces go right through your feet. And so it's just like you're standing. You're at an angle, but you're still standing. Oh, hit the... All right, good. So that is set up. All right, so speed-wise, we're pretty good. All right, so let's see. I need to set this diesel up. So let's grab the... Save this real quick. All right, let's grab the modular engine tutorial. This one will work. This is not... Shit. See. Modular engine tutorial, my latest modular engine tutorial. Let's grab that microcontroller. I will tune that in. Some point, like I said, I gotta do a generator tutorial just so that I have a basis for that. I can just use that microcontroller. Where the hell is it? Right here. Modular engine tutorial. Let's grab that, and we'll just reconfigure this to work. So we'll copy that, and we'll pull the sub. Right. Huh? All right, good. All right, so that is, we'll stick it in the ass for now. Right there. All right, so we need radiator fan. I have no cooling in this yet. Unfortunately, we're probably gonna have to use a radiator. They're still playing around with some of the stuff. I did a bunch of cooling testing. Cooling is fine, but radiators are going to be your most effective now. Water cooling is not. Water cooling is kind of screwed up at the moment, so we're not going to be water cooling, I don't think. Clutch pressure, fuel manifold, I haven't hooked up any of that yet. So let's start putting some of the stuff in there. I kind of screwed up my... what did I screw up? I screwed up my supercharger here. Oh, what did I just put in there? Screwed up my supercharger when I put those motors in just now, so I have to change this up a little bit. Okay, let's grab this, cut you. Go like that for now. And so we'll change this up a little bit. So this is going to be a T-piece going in. You don't need your supercharger to be... You're going to hit the maximum liters per second on the impeller faster than you're going to actually get before you're going to be able to really rev it up. So some people are trying to gear their impellers way, way up. You're going to hit the maximum before you generally do that. So you're just stealing power away from your engine for no real particularly good reason. So generally I don't gear them up. Sometimes I even gear them down because it's just stealing power I don't need. Alright, so this is going to be fluid out. That's going to go right into the air manifold. Yeah, I could actually flip this. Let's flip it, and then I don't need piping at all. So let's go zing zang. Zing zang zoop. Right, where the hell is it? Right there? I can't see. Right there, okay. So that goes like that. This gets flipped. Alright, so that is now plumbed in. Alright. So this is going to go power up. It's going to go into a gearbox, into the generator. I'm going to have to tune that up. This is the air inlet for the impeller pump, which is going to supercharge the engine. Let's go ahead. What do we have on here? I have 2 starters, no alternators. Don't need them because the generator is doing the generation. I might put some alternators on there. Probably not, though. Let's see. Where is our fuel? Fuel is on either side, so it doesn't matter. Let's go right there. All right, now I gotta route this. This is always where I'm like, oh crap! I wish I thought of this earlier. It's actually not bad yet. We're under the shower. All right, that is... I can't go there. Let's get some symmetry on. All right, and we'll see where... Luckily, we're in the floor, so we should be able to run the floor all the way to where we need to. That was kind of by design. Beautiful, right here. That's as far as we have to go. So that's actually really fantastic. Okay, that's really good there. Nice. Okay. I could actually put a diesel spawner here. Let's do that. Alright, diesel spawner is going here now. Alright, nice. And we'll replace the other one. I don't need this one now. Maybe I have a space over here somewhere for the liquid, for the meter. It doesn't matter if I don't, but... Can I cut you? I can cut you, though. Alright, let's get the meter. Liquid meter right here. Alright, liquid meters are now getting moved here. That just gives me my full use of volume. Alright, good. That's done. And then we're going to grab a fluid port. Fluid port goes right there. Nice. Elbow. Go straight piece, straight piece, straight piece. And I guess we could, let's go in here, why not? Actually, that doesn't. That can be cut all together. Beautiful, that's even better. I could cut that too. Nah, that's no point. All right, let's go. Elbow. Straight, symmetry, zing, zang. There, like so. Alright, good. So fuel was plumbed in. Nice. Alright, good. Let's see. What do we need next? That's the X-host. Just gonna do a water push-out exhaust here. Let's see where we can push an exhaust. Curious where we're at here. We're in this. Yeah, can't do it there. Okay, that's fine. Push it out here right off the tail. Nope, not there. We can do the lower one maybe. Do the lower connection here maybe. Yeah, okay. Exhaust can go out there. Okay, there's our exhaust. Gonna go there. Symmetry. See if our exhaust gets choked up. If we will, I'll try to do a less restrictive exhaust, but we'll see what's up with this. Hopefully, we're pretty restrictive now. If it works, we're good. All right, good. So there's exhaust. Okay, so that's good there. So those are the main elements we need to just operate. Exhaust, fuel, and air. All right, so air. I need to take air in, but I also want to have the ability to store and pressurize air so that we can utilize it over time. So let's see. So I'm thinking of pressurizing this whole compartment. That's one thing. We could also do storage tanks, which is probably what I'm going to do. So let's do this. Let's go... We'll do a simple air filter. Okay. And we'll pressure, so it'll suck from this room. And then what we'll do is we'll do some tanks because I can pre-pressurize tanks. So we'll grab, see what a medium looks, or what's a large look like? Yeah, large is large. What a couple meads look like. I'm gonna do meads. All right, so we'll do a couple meads here. That's big. That's long. That's troublesome. So let's see. So what we'll do is we'll grab some pressurized tanks here. That's quite a bit of air. And so what we'll do is we'll go... I'm trying to think where we can pump in from. Right. I gotta find a place to pump in. I don't want to go all the way back there either. I don't want to come up here too much. Yeah, I'm going to have a... Could put a snorkel, would be kind of cool to deal with a snorkel. I don't know if there's space in here for a snorkel. I actually do. I can see it right now. Because I kind of want... This is going to kind of go to the cool factor of it too, if I can get a snorkel in here, so... I do want to add some cool factor, so let's go. Let's try some cool factor. Ooh, that's a bad spot. That's a real bad spot. Yeah, that's a bad spot. Let's see. I want to add a snorkel, though. I really do want to add a snorkel. Put it right here, maybe. Let's see what this sticks out as. See, what do you... Okay, 1x4. Of course, I did that to myself. What are you, in the bathroom? Okay, that's in the bathroom. Huh. Should have thought of that, because now I'm having issues. we do have some headspace in here. So let's take a pivot. And it's going to be a fluid pivot. Put it here. So that's kind of the cool factor I want in here. Okay. And so this is going to be the snorkel. I want it stowed to start with. So let's cut this. And I want to put that arrow on the other side. So like that. Okay. Try to think of how high this has to go. This can be a problem here, but I think we're just about going to make it. So let's see. Let's go right to enclosed here. So I'm going to start in the stowed position, and I want to bring it up. So I want to bring the snorkel up, so I'm trying to think of the best way to do this. So I'm trying to think of the geometry off the top of my head. It's kind of struggling right now, so I'll just do it like this, and then I will work the geometry after that. Okay. Kind of got some of the geometry in my head. All right, good. Symmetry can go off now. The problem is it's pretty damn short. Doesn't need to get that high, it just needs to get up the height of the air. So it's 2 more blocks on top of that. Let's see. Could do the buoy. If I can get the buoy small enough, I can do a buoy. I've done buoys before. Let's grab a air filter. Start with a gas exchanger. Might just do it as the new fluid port. Kind of like the look of that. So let's test the snorkel out. I want to see what that's going to look like. Just going to quickly box this out so that it doesn't leak. All right, box that out so it doesn't leak, and I want to articulate this and see how high this will get. So let's do some throttles. Let's run that. Hopefully I didn't leave a hole in there. It sinks the Davy Jones locker. Nope, it's back up. All right. So this is it floating. It's actually going to float a little bit higher. I have to readjust the ballast. It's going to float so that the barely the surface of that touches. So I have to keep that in mind. Okay, that's hitting I accidentally put a block in the way. Right. Did I? Right here is a mess. That's a problem there. Just do this for proof of concept. I'm going to change this all up. So I might do I'm going to probably do a buoy. I don't know. We'll see. All right, so that's the snorkel. And it's going to sit much higher, so it doesn't need that much of a snorkel. But I kind of like the idea of a snorkel, so that's kind of... All right, so some idea of snorkel. This isn't gonna be it, but again, they make it so that the parts are huge. It's tough to get some of the stuff to work the way I want to. All right, good. All right, so some proof of concept on that. I can kind of work with that. Let's go. Where can I dig this into? It's the problem. It's very low. Parts here. Trying to think of a cooler snorkel to do. Could do a floating snorkel. That would be neat, but I don't know if I'm gonna have the space for that because pretty much winch-wise, could do this winch. I've got 100. What do I have? 40 meters of rope. This one here is 150 meters of rope. Yeah, that's not gonna fit in anyway. But not that I even want it that big of a snorkel, because I pretty much want to fill this one at the surface. That's kind of the goal, is just to fill this at the surface. So I'm trying to think where I can hatch this out. Do that. Okay, I'm trying to think. Hinge could work. I could do a hinge. Let's seal this volume up there. Okay. Yeah, I could cut a hinge in here. Let's do that. Try that. Let me see if I can run anything in the walls here. I could put a snorkel somewhere here. So, I want it for the cool factor. That's the main thing, is having a snorkel there. It's not, it's not designed like some of my, I've built buoys before where it's designed to actually like go down 150 meters and still be able to breathe. I don't want that. I want it stored in tanks. That's kind of the whole nice thing with the pressurization update now, is don't have to do that anymore. I can do it, a little bit cooler and different. See if I can route. I should be able to route some of this here. Let's go try this as a snorkel here. Put a high snorkel on like that. Put a rear snorkel on like this. Cut in here. No, I can't cut in there. Put a basic snorkel in like this. I just want it for coolness. The main thing for me is I want it to be kind of cool. So. It's not going to have a periscope on it. Could have a periscope on it. No reason why I can't. Let's see. I might be able to route around the bathroom and get this routed in. So let's actually do right there for now. Start cutting in here. Okay, so I need to get the shower top is essentially what I'm looking to do here. So let's see, can I get to the shower's top? I don't really need to. Oh, that's a door, so I can't cut in the door for sure. All right, right here. Come down. What are we looking at here? I could put a pipe in there. Exposed pipe wouldn't look too bad inside of a submarine. It's kind of its job. Where are we here? Let me see. Can I get over that far on the door? I don't think I can. Ooh, I might be able to. No, one block short. One block short here of where I need to be. Oh, actually, we're going to do it. No, we can't do it. Shit. Routing is a pain. What is that? Yeah, we gotta put one pipe in this whole thing, so it's not the end of the world. So we'll just stick one pipe in here. All right. So they used to have diesel subs that would have these snorkels on them, and so that they could, you know, mostly stay. The body would be submerged, and the snorkel would be able to take in fresh air to recharge the system. So that's kind of what I'm doing here. Is gonna have a snorkel on the back there that will recharge. If I could do a 1x1 pivot to pass, I would fold it, but I can't. So yeah, I'm not a huge fan of how it's gonna look if I try to do it. So all right, so we'll go in here. This will get some paint. Let's paint this a little bit here. Okay. Now we'll bust in here. Okay. And that's going to be just a pipe. All right, good. So that, I don't hate that. So that's not bad. A little bit of detailing. I'll kind of take it as some detailing, you know, just a detail. And then I'm just cutting out any excess weight I can. So just dump a couple blocks there. All right, so this is going to be the air in. So this will get pressurized into these tanks. So the tanks will put 1 atmosphere of air into this room. So I'm going to put an automated system on this where essentially a valve will open and close to maintain 1 atmosphere in this room. And then so what's going to happen is these tanks are all 6 of them are going to be full. So as the engine utilizes the air in the room and spits it out as, you know, exhaust, the air pressure is going to go down in this room as the engine's consuming the air. That's going to cause a valve to open up and let some air out of these cylinders. What's going to happen? So the cylinders are going to keep this room at 1 atmosphere. Eventually, these cylinders are going to run out, and it's not going to happen anymore. Then you're going to have to surface, and you're going to be able to, you know, you'll be able to run on battery for a little bit, but then you'll surface, and you'll use the snorkel, and it will pump air back into the cylinders, essentially. So that's essentially what's happening here. So I think that's kind of a cool system. All right, so we will do pumps. Semiometry's on. All right, good. And I need to put an air valve in there, a gas only in there. Oh, it's already in there. That's on top, so that's fine. All right, so that is good there. So this is going to come down. Right here. All right, so this will connect there, so the air pumps will put air in the system. All right, then we take a variable valve. Doesn't have to be a variable valve, but we'll make them variable valves. And then what this is going to do is it's going to go gas, fluid port. All right, so this is going to feed our engines with air, or feed this room with air. So the air is going to be vented into this room. The engine itself is going to consume the air from the room. That way, we're not having to worry about the engine eating up super pressurized air, burning a ton of fuel, making super power, and then it lags like a dog when it doesn't. So that will help out. And then what I think I'm going to do here is this will be a hybrid system. So we're going to add extra clutches. Ugh, gross. That's going to be sucky. Yeah, it's going to be sucky to add extra clutches. Doesn't need to be a hybrid system. We'll go without for now. All right, so these are all full there. Let's go make a quick microcontroller for this. All right, so did I just type in black microcontroller and not click on it? There we go. All right, so this is going to be the let's see, engine, room, pressure regulator. All right, so there's the engine room pressure regulator. So it's going to take the atmospheres of the room, and then it's going to feed out to the valves. So this is going to be number input baro in, baro. There's going to be number output. This is to valves. All right. So we're going to essentially read the barometer in. It's going to go into a PID. Presently, it'll be constantly on. I'll improve it later to make it so that when the engine's turned on is actually when it operates. So the barometer is going to be our process variable. We're going to do a constant. So this is desired air pressure. All right, so desired air pressure in atmospheres is going to be 1. So we're going to do 1 atmosphere in here. And that will just be configurable. So that will be that. That's going to go to the valves. Actually, want to do a function first. So do a single function here. All right, 0, 1. Now I'll control the valves. Probably want this number really pretty low, so let's do a really low number on that. Okay. Okay, so that's that. That's gonna go. I need a barometer. Let's find a hole I can cut in here and stick a barometer in. Why not this right here? There we go. Okay. So stick a barometer in this room. Right, let's paint that. Okay. Paint this here. Okay. And then the barometer will go to there, and this will go to the valves. All right, so that should work to keep this tail section constantly full of 1 atmosphere of air pressure. The engine will then eat that air, and as the engine consumes air, it will slowly let the tank volume in. And then there'll be a snorkel system where essentially the snorkel you'll raise the snorkel when you're at the surface, and it will turn the air tanks on, and it will repressurize those tanks. So, hey, how's it going there, Lord Bison? So not only that you'll have a storage of air, but when you go up to surface, you'll replenish it. So, all right, so let's hook on the rest of this engine stuff. Let's get this engine configured for power generation. So it's really not all that much to do. I need to do cooling at some point. Battery, we're running off of these batteries here. This is our battery banks up front. So that's the job of this, is just to keep the batteries tuned, essentially, or maximized. The clutch is going to change a little bit. Fuel manifold is going here. Alternator is going to go to we'll keep auto clutch will stay the same. Alternator, we don't need any more. Air manifold is right on top here. Okay. RPS. Coolant pump, I need to hook up alternator. Those two can actually go. This is going to be engine. And for now, we'll run this off the seat. We'll change it later. All right, so let's go in here and let's configure this for power generation. So what we want to do is change up how this runs. So what we'll do here is we'll keep an engine idle. We'll keep a max RPS. The difference is here, I use WS to feed engine data. Let's keep it like this for now, and what I'm gonna do is I need to tune in the gearbox. So let's do that. So what we're gonna do here is let's see. Okay, good. So currently going to this, I have a 9.5 going to the generator. I'm gonna make the second ratio. I know 3-1's too high, but we'll do that. I will do the 6. Nope, can't do 6 key. Let's do the 3 key on the seat. That will toggle the gearbox. And I will do a dial. And it's going to tell me how much power I'm making. So I need to tune in this gearbox on that generator. So we'll do S watts. I think we hopefully should be good to go. I'm hoping. Okay. Start up. I have input electricity still on, but the rest, we taking in air fine? Yeah, taking in air off the, let's do that. I need to pump this out into the air. I have too much weight blocks in here. I need to cut some out. Wait for this to equalize. Alright, door is like, once I'm under 1 liter, I can open that door. Alright, good. So let's see. Let's go ahead and I'll shut the music off for a second. I start the engine with 6. Alright, so that's something's up. That's not getting a good start. Let's kill some of this ballast weight in here. It's since I had the fuel, we're way too heavy. So we're sinking towards the back. So what we'll do here is I'll turn on semiometry. And we'll cut 4 battle cannons out of there. Let's paint this. Okay, that's good. Let's paint this really quickly. There we go. All right. Let's see what's wrong, why this won't breathe. Okay. It's not necessarily not breathing. Fluid in. Okay, that's good. So that means that's fluid out going into the air. Exhaust. Let's make sure we just have exhaust hooked up. Exhaust going down and out. That out. Good. That's good. Fuel. So it's possibly a culprit. Did I hook up the fuel manifold? I'm pretty damn sure I did. Yeah. Fuel's right there. I hooked up the engine composite. Engine composite's connected. Okay. Let's see where we're at here. Starter, of course. Air is hooked to air. Let me check it again. Air, okay. Fuel. Fuel. Okay, good. RPS is plugged in. RPS is plugged in. Okay. All right, so why this is not kicking off here. Should be enough air in this volume to do it. So let's hopefully see what's up. I can't. I'll try to see if I can squeeze my narrow ass into that space there. So let's get this floating room a little bit better for the second. It's going to help me do some stuff later. So I'll grab out some battle cannon here. Do all 4 there. And I'll grab a little bit of bow stuff here. Let's grab a couple, cut a couple. See how we float now. That's where I want. So see, I want it to just barely the deck awash right there. A little bit more. Take the time to get that right now. Okay. Let's try that. So that is about yeah, that's about how I want to sit. The stern's a little bit low still, but that's about where I want it. So a little bit off balance, but we're close. Okay. I also don't want that center of gravity coming up too high, so I have to keep that focused as low as I can still. But it's sitting much better now, so that's about how I want it to sit. And we can pump water in. The water is going to the lowest part of the submarine, so we still have a nice low center of gravity as we ballast up, which is good. So let's see why my engine's not starting. We'll see what it is doing and why it is not getting enough resources to operate. Exhaust is showing 0, which is fine because we're not lit. Let's see. Let's see if I can get to components. I should have gone on the other side of the engine. I can't get really around in here very well. Oh, come on, man. I hate this sometimes. Trying to get in and out of the build with no clip. It's a pain in the ass. Thoroughly a pain in the ass at times. I'm stuck under this pipe, so I can read my fuel. My fuel's... Alright, it's showing me no fuel, so I need to see what's up with my fuel routing. I've skipped the spawned in. Let's check the fuels. I did change some things around, so I might have put a hole in my fuel tanks, which would be beneficial because that... Yep, no fuel. Okay, that's it. Perfect. That's an easy fix. So. Now, what are you? Diesel? Okay, you should be... Why are you not spawning with diesel, huh? Oh, there, guy. Let's see. Where is my... Oh, I didn't plug them back in, so we could have diesel. Let's check them. Hopefully, I was hoping it was just the spawner got deleted or something, because that would that's not as easy of a fix. Let's check it again, see if it's fuel starvation, which would be easy to fix. I wonder if I can change the keybind so the slow mode is the same. Yeah, we have fuel, so I gotta look at this. So does it not like taking air out of this room is the question. I need to read the barometer in here. Make sure this is plumbed in. So I'll read the barometer in this room. See what it looks like. Make sure we're getting enough air in that room to start combustion. Looks like it. Oh, come on, get out of the deck. So we're at 0.595, so we have air in that room. What was this one? This was S watts. Let's make sure that all the cylinders have manifolds on them. I thought I did that. Let's double check. So we have top banks, side banks. Do I have bottom banks? Yep, bottom banks. Shite. That would have been an easy fix. I'll check RPS next. I'll see if we're getting to 2 RPS. Should be getting to 2 RPS. There's no reason why this one shouldn't start. With that, sure everything's merged. Ick. Yeah, I'm hoping it's not my air. This screws up some of my thought process of what I want to do here. Try to give this a quick juice of air. See if we can start it like this. Let's see if it starts like that. We have a really high pressurized air in there. See if that starts it. If not, I'll put a... Essentially, I'll just route the air outside. Make sure it's getting air. Oh, come on, man. Get in the build. Being obnoxious. Oh, it's getting old. It's getting old real fast. Just jump in the fucking submarine, you dickhead. In the submarine. Oh my god. Why? Walking around like a tit. Okay. Alright. Let's try a start. Nope. Okay. What the hell screwed up here? Is it merged? It's merged. Okay. That's always something to check. Battery. Oh, you know what? I wonder if it is. Do I have infinite? I should have infinite electricity on. Okay, yeah, I'll check that too. Get rid of this. I'm gonna do a real quick thing here. One more check. Let's cut above this. Okay. Doubt this is the problem, but we're going to test the air out again. Do fresh air from outside. We'll check it. We'll see what it does. Because I doubt that's going to be it, but we will test it. All right. What the hell is going on with this thing? Yeah, so it's not the air, so that's fine. That lets me put my air system back the way it was, so I am kind of glad about that. So it's probably something simple. I'm just... forgot. Okay, let's see. This should work running out of this volume. What is it doing? What is it doing? What is it doing? Check this micro on start. Is it killing the clutch? Should be killing the clutch on start. There's clutch right here. Clutch. Starter should be zeroing out the clutch. Make sure it's not trying to clutch up. Let's put in another dial. I want to check the RPS. Make sure we're getting over 2. Go through some of the real basic crap on this and see what's up with it. This should be running, unless I'm forgetting something simple that I not. Oh my, it's like super slippery and tough to get on with that snorkel there, because I'm on the corner instead of jumping on the flat. So. And it's hitting 2.5, so it's not getting something it needs to run. Flicky camera's the last thing I needed right there. Alright, exhaust's coming down, dual exhaust. Let's cut some of this exhaust. I'm gonna run a straight pipe exhaust just to get rid of the cats. Want to make sure it's not an exhaust problem. It is causing a ton of back pressure. Alright, and then we have clutch running on this other node here. It shouldn't be giving me any clutch. I'm not asking for clutch, but we'll put it up on that one. What the hell is this doing, man? I don't know why this engine is not running. It's gotta be something stupid I'm doing here. Check it. I literally pulled it off a build that I know that works for this very reason, to bypass some of this nonsense. Alright, what are we at here? That is the composite data off the engine cylinder going to engine. This is going to the seat. That's fine. That all merged. That's all merged. Why are you not running? Air manifold goes to air manifold. Fuel's going to fuel. It's still showing there was no fuel. Let's make sure I didn't screw up something with just a fuel routing issue. That could very well be it. Alright, piped there. Let's check that. It could be a fuel piping issue here. So it's going straight right here. That's it. Okay. I did diagnose it with fuel, and then I ignored it and didn't go on after that. All right, that was it. Makes sense. All right. Tiny little error, and makes the engine not run. Perfect. There we go. All right, good. We're running. Alright, so at present, let's see, what's the clutch doing? Clutch is at 1. Okay, good. Alright, so I'm curious, it's probably letting too much air pressure in that room. Let's check it over here. Nope, it's not letting enough in. Okay. So I need to work on, it's probably an air issue of why this is going nuts. Because you notice the air pressure is down. It's decreasing pretty slowly. Let's work on that. I gotta get this air pressure working in this room here. So we have the 2 valves. We have a barometer in there. Okay. We have a pit in here. 0.001's got to be too low. So let's dump that up. Let's actually do this. Let's go there. Edit the microcontroller. We'll go wide on that. We'll add a node. I'll tune in the p-value right now. Number input p-value. P-value. Okay, good. Update that. Let's get back in the microcontroller. Where are we at here? There it is right there. Okay, let's go p-value. Update that. Let's go grab this node and we'll hook it to this keypad. I got rid of all my keypads, I think. Did I get rid of all of them? I did. Okay, let's get a new keypad. All right, so I want to tune this air pressure so that so the engine room stays at one atmosphere the whole time. That's the whole point of the system. All right. So let's, I had it at 0.001. Let's go to 1 for now. Air pressure is at 95 and slowly climbing. Perfect. So that's, you notice it's going up. So it is, the valves are working, they're opening, and it's letting air into the room so that the engine can breathe. Let's start the engine. Engine started. Okay, let's go rev up the engine. So the engine is eating. You notice the engine is eating air volume. Notice the air volume go back up. The pit is letting air back into the room. So that, we might have to work on the p-value on that a little bit. This could be I'm overstressing the engine too, but my clutch isn't changing, so I don't know if I'm overstressing the engine. So this is working really well. This is keeping that air pretty damn close. We're at 1. Let's try a 2. That should increase the rate at which this gives air to the room. Let's go to 10 really quick. 10. Okay. So that's a little bit faster. You know, that's keeping us closer to 1 the whole time. So I'm happy with that. So I'll work on the p-value of the actual engine. P-value of the engine could be a little bit weird. The clutch is doing its job. It's at 1. Okay. So let's work on the p-value. Let's actually first start with this. Let's change this clutch to, or the gearbox rather, to 1. Let's go ratio by ratio on this. It's a little bit of a chore, but it needs to be done. So we'll do a toggle here. No, I said it was 3. So I hooked up 3, right? 3? 3? 3 is hooked to that gearbox. Okay, good. So we can use 3 on the seat to change the gear ratio. Let's go ahead in here. And I'll play with the p-value in the event that I need to. This is p-value. Okay, number input. All right, so this is going to be able to work the p-value of the engine. And then we'll use this keypad over there. This is going to be air press. This is going to be engine. All right, let's tune this up. And I'll see you later there, Zachy. Thanks for hanging out. How's it going there, Emery? All right, start it up. So this was at 0.18 before. There we go. It starts. Start cranking it up. Let's make this air pressure was 10 was a good number for us. So you notice it's keeping this room nicely. As you can see, it is opening the valves, letting air into the room to keep us at 1 atmosphere. So I'm happy with the performance of this number at 10. That's good. That's clutch. Clutch should be at 1. We're having oscillations, which is fine. So what I need to do is, likely we're jumping around too much. Let's go 0.1. Wonder if that's an exhaust issue. Let's see. Are we puffing out? Yeah, we're puffing exhaust. It looks like it's not having problems. I'm gonna go back and check that exhaust before I dick around with the number too much. So let's go back to 0.18. Because I don't think this number should really change. So it could be an exhaust issue. I want to see what the exhaust is doing here. Because I could be choking out that exhaust, which would not surprise me at all. So, let's see. If I'm choking out the exhaust, that would cause some of these problems too. So I need to get in here where I can read exhaust values on the engine. Okay. Yeah, that looks like we could be having an exhaust problem. Yeah, I'm reading the clutch, so it's not that. Air is pretty steady. Air is not bad. Air is steady. Let's see if I can read the air. Get it pretty steady. The throttle's all over the place, but that could be because of the exhaust. Okay. I have a question. I have a save. If I create new save, the other one will be deleted. It shouldn't be. Just start a new save. Or you save it as, like I save mine as backups, like, you know, I'll bring up the world and I'll save it as the same name, but backup. It won't delete the old one. If you use the same name, it will write over it, but if you use a different name, it won't. So I'm kind of thinking this could be an exhaust problem. Let me see if I have any other place I can route the exhaust out. Can't go here, I don't think. What's that? I don't know. Okay, that's the power input. Okay. So we don't want to cut there. That's on top of the engine. I can't go there at all. Okay. I can run high and put more exhaust through here. Okay. Trying to get enough exhaust out so that I know if it is or it's not an exhaust problem. Let's not go drastic yet. Let's do this. Let's go one exhaust pipe. Could do exhaust deletion. I'd have to ask Big Man if he considers that a glitch. Come on, symmetry. Get out of there. Give me no symmetry. There we go. Okay. All right, there. All right. And then I will cut out this piping because exhaust can be very temperamental. You got to be careful with exhaust. So we'll test this out, see if exhaust was the issue right now. There's a good chance exhaust, because it's temperamental, could have been the issue. And if I can simplify the exhaust, could fix it. Oh, I know what it is. It's rev limiter. It's rev limited. That's what it is. I don't have... that's exactly what it is. All right, that's me being silly. It's rev limiter. I'm hitting the rev limiter. That's it. There's nothing wrong with it. It was the rev limiter. Okay. That makes sense. It's the rev limiter. It's bouncing off the rev limiter is the issue currently. So that makes perfect sense. All right, perfect. I would guarantee you that's the issue that I think it is. So I think it's the rev limiter. So let's go and assume it's rev limiter. Let's fix it to rev limiter, and I think we're good if I do that. It's bouncing off the rev limiter, so what I can do is I can actually increase the gear ratios on the generator, and it will not bang off that rev limiter. It's hitting the rev limiter, and it's coming down, and that's what's happening. So I'm pretty damn sure of that. So let's go like this, like that. Okay, let's symmetry's off. All right, let's go ahead, put symmetry back on. Let's let's gear this sucker all the way to a 3-to-1 and see if it still does it. Let's go 5-2, 3-1 on this. Make sure it's facing the engine. Yep. Okay, let's check that out. I think it's banging off the rev limiter, and it's that's what it's doing, which is actually what it should be doing, is banging off the rev limiter. So, all right. What we'll do is we'll load it up though, so that it's not. Yep, that was it. It was banging off the rev limiter, 100%. Okay, so it took me a little while to figure that out for some damn reason. So, all right. So now this is pissing air into that room so that it is. So that's fine. Huh, interesting. Trying to see what my max is on this. Let's press 3. Okay, so we're making a good 230, 200, yeah, about 220. So notice it, when I increase the gear ratio, notice how it started to behave again? That's what it was. It was underloaded, so it was hitting the rev limiter and then going up, down, up, down. Now notice it's stable, so we're good there. And that is the, this here is our electrical production. So a 3-to-1 ratio is, the reason is my rev limiter, I bet you, is set to 10 RPS. And so what was happening was every time it went over 10 RPS, it was chopping the power. And I didn't have the generator geared up high enough. So that seems to be the case. So that's good. All right, good. That fixes that. You cannot what? It says, I working on oil 3 to 4 days for refining oil, but I cannot blank, and I don't know what to do. You cannot what? I don't know what the rest of the statement is there. All right, so that's good. Let's save this. So that's working pretty well so far. So this is probably 10's too high. Let's go with 2.5. Let's go with a 5. I think 10's too high. This is going to open up the valves and let air pressure into the room. That's all that's doing. The rest of the numbers are working fine here. Let's fix this. So 1.8 is fine, because that's my standard number. I use a 0.18 for most of my engines, so I was like, I don't think that needs to change, and it didn't. P-value can change. We're going to need cooling in here. I'm going to do that, and then we'll probably take a break here and get off. Let's see. That's going to cut into space. Let me see what I have for spacing for cooling here. We should be all right, actually, I think. We're gonna overdo the cooling. I'd rather overdo it and be all right than underdo it and be screwed. So we're gonna do a couple 5-bys here. All right, there's some 5-bys. Have them out. Where the hell is the nozzles here? I would rather do water cooling, but it is not presently working very well in game, if at all. So can't do it because it's not really working. I tested out a 3x3 radiator running a large generator, and it needed 3 to 4 5x5s, and it was running cool as can be in the arid biome. So cooling is working. You'll still see some people saying, "Oh, cooling's broken." It's not. It's working. It's kind of, you may not have your systems running correctly, but it is working. So keep that in mind. Okay, I'll route this way. Yeah, I should be able to route that way. Try this. Problem is, let's see if we can do it with one pump. Yeah, I think we should be able to do it with one pump. They boosted the pumping really high. So we should be able to do this with one pump. Let's actually undo a bunch of that here. Yeah, let's go to here. And then they boosted this. They boosted this by quite a bit, the devs did, so. Trying to see if I even want that high. Yeah, I kind of need it. You're going to be a pain in the ass with space, aren't you, guy? Yep, you are. Okay, can I come one forward? Not really. Okay. Rotate maybe and pop it up. We'll try that. All right. So trying to see how I can get this in here. Let's go. Okay, like that. Let's try to run this. I want to see what the flow rates are on this. So I was getting like 200 something liters per second. It was insane. Like they really boosted this up. So you know, I did some tests with the other cooling methods, like the other parts, and those weren't working at all. So the electric radiators are working. The pump rates on the pumps are very high now. So, all right, so that is cooling. Let's just quickly. I'm gonna do a toggle. Yeah, toggle. And I want to see the rates. So let's see. You. Okay, and then what do we have on here? We have temperature. There's just temps on here. I can't really get the flow rates on these unless I get in the room. Can I still... I'm going to try to no-clip in there again and see if I can do it. Might have problems me getting in the room now. That takes up a lot of space. So I want to see what the flow rates are on that. Alright. Alright, so I can read it. Yeah, see, we're doing 184 liters per second in here. Note, so one test you can do is look at the temperature. The temperature's going down. That was some testing I was doing yesterday. I was just cycling water through some of the other coolant stuff, and it was not losing temperature. This is losing temperature. I don't even have the radiator fans on. I'm just cycling through. These 5x5s are boss right now. This is the way to do it now. So if you're having some issues, you're going to have to run some electric radiators until they hopefully kind of resolve some of the other stuff. Yeah, so these are at 184, 184. My best case, I think I saw last night, was like 260 something. It was nuts. But you notice the temperature is going down. I'm doing nothing. So I'm hoping, I think that should cool us fine. So we'll delete this. Delete that. This one here, we can come in here and radiator fans can go to the pumps. And it can go to the radiator fans as well. And that should cool that fine. So we're making 232 S-watts. So what I want to do before I take a break here and get off is... there's a lot to hook up. All right, let's... I'm going to hook up like systems, and then I'm just going to bang them to the motors. Bang them to the batteries. And then I will change this and make this a more realistic electrical setup later. I just don't want to do it right now. All right. So I'm just going to hook everything in the generator at the moment. Through the generator, let's put it that way. I'm just going to do a quick speed test. That is a part of the challenge that's important. I need to have the speed be at a certain rate for Big Man's challenge. That I can't get around that. I don't want to get around that. So because of that, I really need to make sure that I can get to the 20 knots that he has asked for. So starters are good. This was a 3-to-1, was even too low, frankly. So I could probably go even. I need to go higher on this gear ratio. Do I have the space? Not at present. That's sucky. I can route around. It's not a big deal. Put a gearbox, couple more gearboxes in there. I can do it. But yeah, I can do it. I can cut through here and fix that. All right. So we won't worry about that later. I'll tune that in. I just want to get this electricity hooked up really quickly so that I can test out the generation. So this is all batteries in the front wall here. Now, all this is batteries here. What I'm connecting right now. Small batteries. And this one battery I wanted to flip because it's upside down. All right, so that's all the batteries connected there. Let's go ahead. I'm just going to do this test really quickly. So we're going to plumb this into there. That's all plugged into the gen. This stuff's all plugged in. We'll plug that. We'll plug that in. I don't need all of these systems to run, but... all right, so we're going to just go do a quick speed test. This should be able to turn the engine on. And I want to see, is the engine powerful enough at present with the generation we're producing to keep the batteries topped off? Hoping it is. I can still increase the gear ratio on that generator, so that's something I can do. All right. So I'm gonna crank this engine up to max. So at max, it's producing around just under 230, 225, something like that, S watts. All right, and I'm gonna start slowly going forward. And I'm gonna shut off the infinite electricity. What's up with my, what am I doing here? Oh, I used the wrong thing. Okay. I was trimming my pitch trim. Right, so we are going currently 20 knots. Check our battery. Why is okay, those aren't connected to electricity. I need something connected to electricity so I can see what's going on here. Shit. I didn't connect any of this to electricity, so I can't tell. I need to connect at least one gauge to electricity, or I can't tell what's going on with my batteries. So let's hook this up to this gauge here. It's fine. All right, let's try it again. I was trying to see if my electrical production is enough to power the ship. Why won't you start the engines now? The fuck, man? Why won't it start the ship? God damn, what happened? Literally, it was, I started with infinite electricity, so this is not plugged. That is, yeah, these aren't plugged right there. Okay. I had infinite electricity on when I started last time. The starters were disconnected. That's all it was. Okay. Simple fix. There we go. All right, so we're going to rev this. I screwed that up. Okay. We're going to feed this a number real quick. We're going to feed this a constant number. Problem is my WS does my pitch, and my WS is also doing my generator. So I need to feed this. What are you connected to right here? I need to feed this constant number because I can't do WS or else my pitch fins will misbehave. So I'll just feed this a max value of, what's the maximum on here? God, piss off. Let's do 1 on there. Okay, update that. All right, so that will fix it so that my pitch fins, because I have, this came out of a car, so WS was the throttle. And now WS is pitch fins, so, all right. Rev this up. All right, it's going to rev itself up, so I don't need to rev it up anymore. All right, so that's going to make maximum electrical production. We're up over 223. I can read my electricity here. Come on, man. Click every wrong button. It's going to take me 100 years to do anything. We are currently infinite electricity off. Let's go ahead, start going forward here. So I want to see if I can go maximum speed and not eat up my battery, which we'll see. All right, that should be maximum there. All right, we're slowly eating our battery. It's not very bad though, so I can still gear this generator up. I'm making 10 RPS. I can gear that generator up and make some more power. I have some other things I can do to get a more powerful engine, so I think we'll be all right. This is not working presently. I don't know why. That needs to be fixed. I'm not getting, it's probably an electrical problem. So we're actually pretty close to where we need to be on this, so that's not bad. So let's go underwater. Remember, we are using the air from the tanks in the room to power the diesel. So we can actually run the diesel underwater because of this room. Now the room's not equalizing, but we're using the air in there, so we have store air tanks that's feeding our diesel. And so once the stored air tanks are empty, we'll come to the surface, the snorkel will extend, we'll refill our air tanks full of air, and then we can go down. So this will allow us to run for an extended period of time because you're going to eat your batteries up really quick. Trying to just do do an electric run. So this will give us a really nice a bit of time. I wanted a picture, but this picture kind of sucks with microcontrollers sitting all over the top of it. But yeah, so that'll work out well for us. So I think some good progress with this. You know, did some good progress today. Kind of got a bunch of the stuff that needed to be done. Engines up and running. A little bit of tweaking. We'll turn that into a power generation system so that it automatically changes themselves. Yeah, I'm not sure what you're saying there, Emery. You're saying, okay, thanks. I've been working 3 to 4 days on refining oil, but cannot, and I don't know what I should do. I don't, go to the Discord, ask in build help, and try to be specific. Like, are you having problems fractioning? Are you having problems drilling? Are you having problems pumping? Like, what is the actual problem? Because, I would need specifics to help you out with that one. All right, so thank you guys to the members. Thank you, Sada Mountain, Connor Boyle, Danny, Sergeant Chaos, Aaron Repairs All, and FS Gamers. I appreciate you guys for being members. If you guys would like to be members, you can check down in the description below. Thank you to Chicken Soar for being a patron. If you'd like to be a patron, that's also down in the description below. Thank you to all the subscribers. If you have not subscribed, please consider subscribing. That way you can see what I'm doing, and I always appreciate that. If you have not liked the video or videos, I appreciate if you guys would like the videos. That helps other people find my content. Thank you guys for watching, and I'll see you in the next one.